solved example 10. Here they have given angle C means angle ACB is 90 degree, even CD is perpendicular to AB. Here we need to show that BC square divided by AC square is equals to BD divided by AD. We need to show. We all know that by the theorem 2.7, if CD is perpendicular to the hypotenuse side AB, then obtained two triangles will be similar to each other, and also those triangles, obtained triangles, will be similar to the bigger triangle, isn't it? Using this theorem, we'll say that, or we'll prove this. Here, given angle ACB is 90 degree and CD is perpendicular to AB, right? Already they are given that CD is perpendicular to AB. So there is no need again constructing it. We need to show that BC divided by AC square is equals to BD divided by AD, right? Proof. First, as we done in Pythagoras theorem, first we'll consider one small triangle and one big triangle. So the small triangle is triangle ACD, and one more triangle is ABC we are going to consider, right? So triangle ACD, these two triangles are similar, and one more triangle is triangle ABC. Why? Because CD is perpendicular to AB, or we can write it by theorem 2.7. Now, if these two triangles are similar, what about their corresponding sides? They are in the same ratio. That is, first we take AC of a triangle ACD. Of triangle ACD, we are going to taking a side AC, and now I am going to take a side AB, is equals to, because here we have taken angle ACD, right? Triangle ACD, we have taken this angle, it means, and here one more triangle we have taken ABC, means this angle we have taken, right? So we have to write the side, that is AC is a side of a triangle ACD, and BC is the triangle of a triangle, BC is the side of a triangle ABC, isn't it? So we have to, so I have written their sides in the ratio, and one more side we are going to take for the triangle ACD. For this triangle I have taken base AB, right? AB I will take base. And for the triangle ABC, the base is AC, yes or no? So AC. Again the cross multiplying will get AC square is equals to, sorry, this is not AB, this is AD, right? Cross multiplying will get AB into AD, right? We'll call this as equation 1. Similarly, we'll compare the triangle, small triangle and one big triangle. Similarly, we are going to take the triangle BCD, right? BCD, this, and one more triangle, that is BAC, this angle. Triangle BCD is similar to the triangle BAC, right? If these two triangles are similar, then the corresponding sides are in the same ratio. For the small triangle, that is triangle DBC, BC is the hypotenuse, right? So hypotenuse divided by, then hypotenuse for the bigger triangle, that is BA or AB. We can write that is equals to, one more corresponding side will take, one more corresponding side will take BD, this side BD is the side for the small triangle, right? Even we have to consider side for the big triangle, we'll take BC as the side. BC, again we'll cross multiply, we'll get BC square is equals to BA into BD, this is BD, right? Now adding 192, add 1 and 2. Here we want to take the ratios, isn't it? So to take the ratios, we have to divide equation 2 by equation 1. Equation 2 by equation 1. So we can get it in a ratio. Equation 2 is BC square is equals to, or we'll write BC square divided by AC square. BC square means BA into BD, then dividing by AC square means AB into AD, right? Now this is BA into BD. Now BA or BA get cancels, so the remaining thing is BD divided by AD, right? So we can write, therefore BC square is divided by AC square is equals to BD divided by AD. Hence we got the required, or we proved this, right? You can observe this. Hence this completes 10th problem. 12th example. If AD is perpendicular to BC, here we need to show that AB square, that is side AB square, is AB square plus CD square or DC square is equals to what? BD square, this side, BD square plus AC square, right? The sum of the squares of BD and AC is equals to what? The sum of the squares of AB square plus DC square, right? We need to show this. Let's begin the proof. Here first we'll consider the triangle BDA. In triangle BDA, we are going to apply now Pythagoras theorem, right? Now it is right angle at what? Here D, isn't it? So now we'll say that AB square is equals to what? Hypotenuse square is equals to BD square plus DA square plus DA square, isn't it? By Pythagoras theorem. Next we'll take the triangle ADC. Again in triangle ADC, again AC square is equals to what here? AD square plus DC square, isn't it? Again by what? Pythagoras theorem only. Pythagoras theorem. Now we'll call this as equation 1 and this as equation 2. Now we'll subtract equation 2 in equation 1, right? Subtracting equation 2 in equation 1. So we'll write equation 1 first. In equation 1 we are subtracting equation 2, right? So we have to write equation 1 first. AB square minus then second equation, that is AC square, is equals to BD square plus DA square minus AD square minus DC square, right? So you can observe that plus AD square minus AD square get cancels. Now BD square minus DC square, we got AB square minus AC square is this much. Now we'll rearrange the terms. We want here what they have given? AB square plus CD square, right? So we'll shift this AC square to the right hand side and we'll bring DC to the left hand side. AB square plus, here it is minus, it will be plus DC square or CD square, both are same, is equals to BD square plus again AC square. Hence we proved the required answer. This is what we proved it here, right? Okay, this completes 12th example. 13th solved example. Here BL and CM are medians of a triangle ABC. It is right angle. The triangle ABC is right angled at A. We need to show that 4 times of BL square plus CM square is equals to 5 times of BC square. We need to show this, right? So let's write the given things first. What all they have given? BL and CM are medians. Medians means what? The midpoints. These lines joining the midpoint of the side AB, and L is joining the midpoint of the side AC, right? So we can, and also they have given it is right angle at A. Angle A, and angle A is equals to what? 90 degree. We need to show that, what we need to show? 4 times of BL square plus CM square is equals to 5 times of BC square. Proof. You can observe that here. How to prove which triangles we need to consider for this proof means, here what they have given? BL. BL means what? This side. This side is referring to the triangle ABL, isn't it? So we need to consider the triangle ABL, and one more side CM. CM means again we need to take the triangle, this triangle, and one more they have given 5 times of BC means this side. This side is of the triangle. This is the side of the triangle ABC, isn't it? So we need to take here 3 triangles. We have to solve those 3 triangles using Pythagoras theorem. Later on we have to obtain those 3 results. To prove this, which all triangles we need to consider means, first see, here they have given side BL, right? BL, it is the side of the triangle ABL, right? So we have to consider the triangle BAL, and CM, it is the side of the triangle CM, it is the side of the triangle CAM, isn't it? So this triangle, 2 triangles we got. One more triangle BC. BC means the triangle ABC we need to consider. So to prove this equation we need to consider the 3 triangles, right? Now for those 3 triangles we have to apply the Pythagoras theorem. Then we'll get 3 separate equations. We have to equate those 3 equations. Then we'll get this result. Let's begin the proof here. First we are going to consider the triangle and triangle LAB, or BAL will take. In triangle BAL, in this triangle hypotenuse is what? BL, right? You know how to find hypotenuse, that is the side which is opposite to the right angle. That side is called the hypotenuse side, isn't it? So we'll write BL square is equals to 2 sides are LA square or AL square plus AB square. We'll call this as equation 1. Now you can see that here I am going to replace LA by AC divided by 2, because already what they have said, BL, it is a median of the side AC, right? If it is a median means then L will be the midpoint of the side AC, isn't it? So we can also write that here instead of AL I am going to write it as AC divided by 2 whole square. It is nothing but a LA square only, yes? So I am going to replace this by this now. That is AC divided by 2 and this whole square plus AB square. This is BL square. We'll rewrite it. How to write? AC square divided by 2 2s are 4 plus AB square. This is what? BL square. Similarly, we'll take a triangle ABC, right? So, in triangle ABC, hypotenuse side of the triangle ABC is BC. BC square is equals to what? Again, AC square plus AB square. This is by Pythagoras theorem. Here also you have to write Pythagoras theorem. We'll give this as equation 2. Now we'll take the third triangle. Which triangle? Here we have considered the triangle BAL and one more triangle ABC, and one more triangle we need to consider. That we'll consider now last triangle. Which triangle? That is triangle CAM. In triangle CAM, again CM is a hypotenuse. Square of hypotenuse is equals to the sum of the squares of remaining two sides, isn't it? This is the Pythagoras theorem. Pythagoras theorem. Now again, you know that instead of here AM, here I got a AM, right? So instead of AM, here I am going to write again AB divided by 2 as we have done here. So we'll write here AC square plus AB divided by 2 whole square, right? Because M is the what? Midpoint of AC. We can write here the reason why. M is midpoint. M is midpoint of AB. And here also you can write L is the midpoint of AC, right? Now we got this equation that as CM square. Again we are going to equate this or resolve it. AC square plus AB square divided by 2 into 2, that is 4. This is what? CM square. In equation we want that BL square plus CM square, isn't it? So we need to add this equation and this BL equation. We'll get this left hand side, right? So add, we'll call this as equation 1, not this, right? And this as equation 3. Add 1 and 3. Here it is BL square plus CM square is equals to AC square divided by 4 plus AB square plus AC square plus AB square divided by 4. Yes. We'll write all the like terms one side, that is AC square divided by 4 plus AC square. Similarly plus AB square divided by 4 plus AB square, right? So we'll take LCM for these two and for these two separately. AC square divided by LCM will be 4 only. So plus 4 times of AC square plus LCM will be 4 AB square plus 4 times of AB square. Isn't it? Again we'll take LCM. We'll get 4 only. We'll add all those. A square plus 4AC square plus AB square plus 4 times of AB square. We'll bring this 4 to the left hand side. So we are able to get 4 times of BL square plus CM square. Now we'll add these two and these two. We'll get 5 times of AC square plus again 5 times of AB square. We'll remove the 5 as a common. Remaining is AC square plus AB square. Isn't it? Thus, we obtained the required solution. This was a required solution for us. Or one more step, we can say that AC square plus AB square means here we got it as a BC square, right? So we'll replace this. We'll write from 1 4 times of BL square plus CM square is equals to 5 times of, this means what here, BC square. BC square. Hence we proved, right? Okay, this completes 13th problem. Next we'll move for 14th example. Example 14th. O is any point inside a rectangular ABCD. Prove that OB square plus OD square is equals to OA square plus OC square. Here they have given a rectangular ABCD, right? In this rectangular, inside this rectangular there is a point O. So here we need to show that BO square plus OD square is equals to what? It will be these two squares of these two sides will be equals to what? OA square plus OC square we need to show, right? Here what all they have given? OB square plus OD square means this side and this side, this side and this side they have given, right? Here we have to take a triangle in such a way that those triangles must consider these two sides and these two sides. For that, here I have made a construction that I have drawn PQ parallel to BC and even it is parallel to AD, right? If it is parallel to BC, PQ is parallel to BC means here PQ is perpendicular to DC and also even it is perpendicular to AB, right? If PQ is perpendicular to BC means then it making an angle 90 degree at Q, isn't it? And even at the point P it is also making angle of 90 degree, right? Now, and also you know that already they have said ABCD is a rectangular. If ABCD is a rectangular means angle B is also 90 degree, angle C is also 90 degree. Here we got these two angles are 90 degree and these two angles are also 90 degree. By these four angle informations we can say that P, B, C, Q and A, P, Q, D are what here? Are rectangulars, yes or no? So we'll write this only now. Given thing ABCD is a rectangle and construction. Draw BC parallel to BC. That line PQ is passing through the point O, right? PQ is passing through the point O. This was the construction we made. Now we need to show that what we need to show, OB square plus OD square is equals to OA square plus OC square. Now first what I told, here PQ is a parallel to BC. If PQ is parallel to BC then PQ is perpendicular to AB and DC. right? So if it is perpendicular to AB and DC means then it's making an angle 90 degree at a point P and at a point Q, isn't it? So we'll write here proof, since PQ is parallel to BC, right? Now PQ is perpendicular to what? DC, and PQ is perpendicular to AB here, and also we know that angle P is equals to angle Q is equals to what? 90 degree. Yes, and also we know that angle PBC is equals to angle BCQ. These two are what? Again 90 degree. Yes, by these two condition can we say that PBCQ is a rectangular or not? So therefore PBCQ and one more APCD, APQD are both rectangular. Right? Now at the last step of this proof we want this information, so we proved it before only, right? So now we'll consider triangles. Now we have to consider triangles in such a way that they must have the side OB and OD, right? And OC and OC, OA and OC. First we take the triangle which consisting the side OB. We'll take this triangle. We are going to apply Pythagoras theorem, right? Pythagoras theorem means we have to take a right angle triangle, right? In such a way that we have to take a right angle triangle which consisting OB. Here triangle BPO is a right angle triangle which consisting the side BO, right? So we'll take this triangle BPO. Now in triangle BPO we'll apply the Pythagoras theorem. OB square is equals to BB square plus OP square by Pythagoras theorem, right? Next we'll take one more triangle which containing side OD. Which triangle we need to consider? Right angle triangle OQD we need to take, or we can take DQO. Similarly triangle PQO, in this triangle again OD square is equals to OQ square plus QD square, isn't it? We'll call this as equation 2. This is by again Pythagoras theorem. Even this is also by Pythagoras theorem, we'll call it as equation 1. Similarly we got these two sides. Similarly we have to take these two sides. Now for these two sides we need to consider the triangle APO and triangle CQO. Triangle APO, in triangle APO here OA square is equals to OP square plus AP square. We'll call this as 3 by Pythagoras theorem. Then we'll take this triangle. In triangle CQO, that is OC square is equals to OQ square plus CQ square. Again this as 4 by Pythagoras theorem. Here we obtained 4 equations, right? Here you can observe that we need to show that OB square plus OD square. So we have to take OB square and OD square. We have to add these two equations, right? First we'll do that. Add, this is equation 1 and this is equation 2. Add 1 and 2 OB square plus OD square is equals to PB square plus OP square, again plus OQ square plus QD square. Here I have proved that these two are the rectangular, right? If these two are the rectangular means, can I write PB equals to QC? Yes or no? So we'll write here PB equals to QC and QD equals to AP, right? And QD is equals to AP will take, right? We are going to use this concept here. Did you got why we have proved this first? It is a rectangular. We have to use this concept at the end of this proof. PB means here what I got? QC or no? So we'll put it here. QC square plus, we'll keep OP as it is, plus OQ square plus QD means here we got what? AP. So we'll write it here AP square. Now you can observe that in 3 and 4 OP square plus AP square, right? We'll write them on side and we'll compare them. OP square plus AP square, and remaining two sides are QC square plus OQ square, right? OP square plus AP square means what? OA square. So we'll substitute it here, right? Plus here also same thing. QC plus OQ square means OC square. Then left hand side is OB square plus OD square, isn't it? This was the required answer. This was the, we need to prove it, yes or no? You can observe it here. This was the answer. We have to show this, hence we prove this equation. Hence proved. Right? This completes 14th example. Even all solved examples are completed from triangles chapters. In next video we are going to solve exercise 2.5. Thank you.